now we are going to be trying to find out when the two forces here, the two equal parallel forces. Two equal means they have the same magnitude. In this case, I have taken the F1 as well as the F2. Two forces I have taken. That's going to be F1 is equal to F2. I can say F. Alright. So that because these two have the same magnitude, because the two equal parallel forces acting in opposite direction. So then it will going to be, he's saying that is going to be forms the couple. So in this case, the two forces F1 and F2, they are in parallel in nature because the line of action, they are not going to be intersecting. So then the distance between these two is the D is maintaining the constant throughout the process. And at the same time, F1 and F2, so can you see the direction, one is moving in the vertically downward direction, one is moving in the vertically upward direction. There we can say take in the horizontal direction also in any other diagrams. There is no issue with this one. At the same time, I am going to be taking the observation point is at A. So then the D1 is going to be the distance between the force which is going to be acting F1 is the D1, and the distance between the F2 line of action to the point A is going to be your D2. The distance between the F1 and F2 is going to be the D we are going to be considering. So in this case, what will happen? So when we are going to be taking this part, so the two forces form a couple. The two forces form couple which has the tendency to rotate the object in this case. So then what is that one? That the distance between these two we are going to be called arm of the couple. So that's the D is equal to called arm of the couple. Because these F1 and F2 are going to be the equal, the body is not going to be taking the translatory motion. Rather than it will move, it will start to rotate about its own axis. So then what is the moments we are going to be taking? The moments, the moment of couple, the moment of the couple M is equal to here, I am going to be taking the force into D, I am going to be taking. Either you can take the F1D or F2D also we can take it. That is going to be the moments of the couple we are going to be getting. So this way we are going to be calculating the couple. So if I am going to be taking the moments at A, so then the moments at A algebraic sum that's equal to 0 suppose. So then what are the forces we do have? This force is going to be acting in the clockwise direction. This is going to be moving in the anti-clockwise direction. So that is equal to here, that's F1. So in the clockwise direction, that's going to be the D1. That is equal to F2. That distance is the D2. So this way we are going to be calculating F1. F1 and F2, these two are going to be the same magnitude, but the D1 and D2 are not in the same distance. They are existed in the different distance. Then automatically the effect of this part we are going to be getting a little different. So on this basis we are going to be calculating the moments of the forces. In continuation of the parallel forces here, the resolution of a force into a force and a couple. So initially the body is going to be subjected to a force. So that's what I am going to say. We need to resolve a force. This force we need to resolve into another force and a couple. So in this couple means already we do have seen that the force into the distance we are going to be taking, that body is going to be taking into the rotational motion. But when I am going to be applying this force, the body is going to be trying to make in the translatory motion direction in this case. So I don't want to go with this part. So then I am going to be replacing, I am going to be taking the another observation point, the same body I have taken, and here is the force is going to be acting, then A is. So then I am considering the another observation point, that's going to be at B I am going to be taking. In this case, I am applying the principle of superposition by applying the two equal and opposite direction forces, but they must be existed on the same collinear direction. So then in this case, F is going to be the force acting, another direction is the force is going to be acting. In this case we can see F and these magnitudes are going to be the same, that is equal to F. So then in this case what will happen? The equivalent forces we have applied here, then finally this is going to be the neutral condition. So then by considering this force as well as this force, the object is going to be trying to rotate about this point. So then that is equal to, I am going to be taking here, so this is the point A. So that what will happen, this is going to be converting in terms of, this is going to be the point B. So then this force is going to be acting in this direction, and because of this force and this force, the body is going to be trying to rotate about the point. So then this is going to be your coupled force we are going to be considering. This way we have resolved the resolution of a force into a force and a couple. So this way we can resolve it, and then we can get the solution for this part. So this is C is equal to, I am going to be considering the couple, M is equal to the moments about the point is equal to force into the distance between these two. Suppose if I am going to be considering, that's going to be the force into the distance I can take. So the magnitude of this couple is equal to force into the distance. So the magnitude we got it. At the same time we are identifying the direction, this direction the object is going to be rotating, and we got the magnitude of this, the force, after the resolution of this existed one. So in continuation of the parallel forces analysis and the resultant, now here is the general case of parallel forces in a plane. So in this case what will happen, we have taken the general cases, that is the parallel forces, and they existed in the plane. The same I have shown here is the diagram, that's going to be the x-axis and y-axis I have taken. So then what will happen in this case, assume there is going to be one body is there. Then in this case they are existing on the same plane, xy plane they have. So F1 force, F2, F3 and F4 forces, they are acting at a distance of this y. From this distance x1 is the F1, x2 distance is the F2, x3 distance is F3 and F4 is the x4 distance it is there. So then how could you find out the resultant components in this case? So then already we do have seen there is going to be different, they are going to be the like parallel forces are moving, then what is the resultant component? When they are in the opposite direction, what is the resultant component? When taking the force and we resolve into the another force as well as the couple. And similarly in this case what will happen, how could you resolve it? Can you see here the two forces are acting vertically downward direction, the two forces are acting in the vertically upward direction. Then what is the resultant component for this part? Then we can say that's going to be, these two are going to be in the negative and these two are F2 plus F4 by F1 minus F3 we are going to be say. This way the resultant component we are going to be considering. So for this one I am going to be taking the three conditions. I am going to be reducing into the single force. Then I am going to be find out the moments, and then I can consider that is in the equilibrium condition. So the first condition for the general cases of the parallel forces, so the system of forces reduces to a single resultant force. So how could you calculate the single resultant forces? We are going to be say that I am going to be say the R, that is equal to, what is the formula we do have? The summation of the forces above and by subtracting with the downward forces. So then that is equal to, in this case I am going to be taking the summation of the forces is going to be taking. It's maybe the positive or the negative, accordingly we can consider here. See here, the system of the forces we have converted into the resultant component, that is going to be Fi. This force, what is the sigma Fi that I am going to be taking? Some forces are acting in the downward direction, some forces are in the acting upward direction. So that I am going to be taking F1 plus or minus F2 plus or minus F3 plus or minus F4. So this way we are going to be calculating the resultant component. Already we do have seen when the two forces are moving in the same direction, they are going to have the equal magnitude. The resultant component also existed in the same direction at the midpoint of these two parallel force distance. At the same time we do have seen in the different direction force. The same thing we are applying here. The system of the forces reduces to a single resultant force, that's going to be the F, R, I am going to be say this is going to be the R. So R is equal to, we will get this part. So the second condition from this general forces, the system of the forces reduces to a couple. Already we do have the single force, we reduce it to the another force as well as the couple. In this case the system of the forces are taking, and I am going to be considering this is going to be the point O, suppose if it is. So then I am going to be taking the moments. Then what will happen in this case? So that's the symbol that is going to be the resultant component is equal to sigma F I already we discussed. So then the magnitude, that means the moments about a work is equal to, that's going to be R into the distance I am going to be taking, that's going to be sigma Fi xi we need to be taking. So then in this case I is equal to 0 to, so that's going to be 1 to n we are going to be considering. So this is the way, this is going to be the Rx, I am going to be saying the resultant component into the perpendicular distance between the point to the line of action, that is equal to the individual moments of these forces. Suppose you can take it, this is going to be the line of action, the distance between these two is going to be the x1, and this force is going to be acting, this is the distance is going to be the x2. This is the force and the perpendicular distance if you are going to be considering. So this is the x3 and this is going to be your x1 forces are going to be acting over here. So that's the way we are going to be reducing the total forces into a single coupled force we are going to be generating. So the third condition here is that the system is going to be in the equilibrium condition. That means this is going to be the system of the forces acting on a body that is in the equilibrium condition. When the equilibrium condition is that the resultant component all is equal to 0 and that is going to be the summation of all the forces is equal to 0, we are going to be saying. At the same time, the moments also we told that the resultant momentum of that particular force in a particular point that is equal to the summation of the moments of the components with reference to the same body. So then I am going to say this is going to be a resultant component R is equal to sigma Fy is equal to 0. That's maybe in the x direction or maybe the y direction also we can take it. So next one I am going to be taking the moments is equal to 0. That is going to be R into x, that resultant component perpendicular distance, then the summation Fy xi is equal to 0. So I is equal to 1 to n, the parameters we are going to be considering. So in this case the moments of the forces is equal to 0 and the resultant components of all the forces also equal to 0. So this way when we are going to be making equated to, then the system is going to be in the equilibrium conditions that we are going to be saying. So this way we are analyzing the general cases of the parallel forces in a plane. So the condition is that they must be existed in the same plane, then only these the equations are going to be helpful to find out the unknown parameters.